Hello everyone and welcome to the next video. In today's video, we will learn about how to integrate some particular function. That means we will talk about basically two types of integration where we have a quadratic equation in the denominator, or either we have a under root of quadratic equation in the denominator. Now for this, we will be requiring these six formulas. Three formulas which will be for 1 upon quadratic equation and three formulas which will be 1 upon root of quadratic equation. Now, first formula, integration of 1 upon x square minus a square dx is equal to 1 upon 2a log of, this is how I've learned, the expression in the question x minus a upon x plus a modulus close plus c. Similarly, for the second question, the formula is 1 upon 2a log of a plus x upon a minus x in the modulus plus c. Now, it becomes a little tricky how to differentiate between two formulas. So that is why I've just made the formulas little similar by adding a negative sign. Since we already know, if I will put this formula as minus 1 upon 2a log of a minus x in the whatever is the expression in the question upon a plus x plus c, so that there is no confusion. And why is this negative sign? Because you'd remember that in the first video I told you d by dx of x will always come in the denominator. So that is why this negative sign is here. Now, third formula, 1 upon a square plus x square dx. Again, the formula is 1 upon a tan inverse x by a. Now, this formula you can also remember, if you remember the first video, integration of 1 upon 1 plus x square dx was tan inverse x. So, plus c. So this is the formula which resonate with the same. So whenever a square plus x square term is there, you should remember that tan inverse will come. All right. Now for the fourth formula, integration of 1 upon under root of x square minus a square dx is equal to log of mod x plus under root of the denominator. Yani ki whatever is the denominator plus c. Again, formula number 5 will again resonate with the formula of sine inverse. Again, if you remember, integration of 1 upon under root of 1 minus x square dx in the first video, I told you it was sine inverse x plus c, right? So again, whenever under root of a square minus x square is there, we will have tan inverse x by a. Please remember, with sine inverse, 1 by a never comes. So that is the thing which you have to remember. Question number 6, 1 upon under root of a square plus x square. Again, the formula is log mod x plus under root of a square plus x square plus c. Now, the most important thing, to use these formulas, the numerator has to be 1. If the numerator is 1, if it is not 1, basically, if not, use substitution. That means we will use substitution method to make the numerator 1. The second thing which you have to remember, the coefficient of x square has to be 1. If the coefficient of x square is 1, again we have to remember and put upon d by dx of x in every formula, so which generally students forget. So that is why I have added just a single step extra, so that you don't make this silly mistake. Now, the next step is, you have to note that if the equation is not a perfect square in the denominator, then we have to make it a perfect square. Now, how to make it a perfect square? First of all, the coefficient of x square has to be 1. You will add and subtract coefficient of x by 2 whole square, and then you will combine. Let me just take this. You will combine the required term to make x plus b whole square if the coefficient of x is positive. This formula will be made, and if x minus b whole square if coefficient of x is negative. These three steps will become more clear when we solve the exercise. Let's move on to the exercise. So first thing is, how will you know that where to use these formulas? Now, let's talk about the first question, children. Integration of 3x square x to the power 6 plus 1 dx. Now, this is very clear that in the numerator we do not have 1 children. So that is why we will put x to the power 3 as t. Why x to the power 3 as t? I will explain you that also, because 3x square dx will become dt. That is why I know that cube, if मैं अगर cube को डालूंगी तो मेरे power 2 आ जाएगी, क्योंकि x की power n का डेरिवेटिव जो है वो n x to the power n minus 1 होता है. तो इस क्वेश्चन को can I write it like this, children, to make you understand better? X cube raised to power 2 plus 1 dx. Now the question becomes very simple. It is dt upon t square plus 1. Now again, I have explained you very clearly. X square plus a square without root, यानी कि formula होगा 1 upon a tan inverse x by a plus c. And again, you know this concept of substitution which I have taught you in the second video. That t, the answer should always be in the variable the question is asked. So in place of t, you have to substitute x. So this is our final answer. I hope this method is clear, right, children? Now, similarly, in this question number 2, now I'm not going to solve all the questions for you. You are going to do it on your own. But I will just tell you how to make the coefficient of x square 1, children. So of course you know that whenever we have to make, here x square has 4 with it, right? So we have to divide by 4. Rule of mathematics: when you will divide something by 4, you will multiply also by 4. So this 4 is not required, children. So can I take it outside and write it as 1 by 2? Because I know that under root of 4 is 2. Now integration. If I separate it out, children, so it can be 1 by 4 plus x square dx. Now integration of 1 by 2 as it is, under root of 1 by 2 whole square plus x square dx, right? So this is where you can apply the formula. Now remember, it is under root of a square plus x square. So now the formula which will be used is, let's go to the previous this thing, under root of x square plus a square plus x square. So log of x plus under root of the question. So here the formula used will be log of x plus under root of the question plus c. Now I hope this thing is clear. Now what, similarly here also you can just put 2 minus x as t and you will convert it into dt. Here you will divide it by 25. Again, here there is no problem. X to the power 4 can be written as x to the power 2 raised to power 2 and x square can be put as t, right? Similarly, here in question number 6, we can put x cube equals to t. The question can be solved. In question number 7, children, just a small hint in question number 7. X minus 1 upon under root of x square minus 1 dx. Just separate out, children. Again, I have told you this in the first video. Separate out the terms whenever you think the integration is not going to become possible. So here you will use the normal formula, just now the formula which I have told you, 1 upon under root of x square minus a square. And here, children, you remember the second video where we use substitution method, and under root of something will always put as t square. So we get 2x dx is equal to 2t dt. So 2 gets cancelled. So x dx is t dt. So this part gets converted into t. Okay, please remove both the integration sign together. Again, in question number 8, x cube can be put as t. In question number 9, if you remember, tan x can be put as t because derivative of tan x is sec square x. Now, let's come to question number 10. What's the change? What suddenly changed in question number 10? Now, if you look at the denominator, children, of question number 10, it is not a single term in x. There are two x terms. One is in square, the other one. So in this, we will use the 3 steps to convert it into a perfect quadratic equation. Now, how to convert it into perfect quadratic equation? Step number 1 was the coefficient of x has to be 1, which is already 1. Now, you will add and subtract coefficient of x divided by 2. So, coefficient of x is 2 divided by 2 whole square. So, that means 1 whole square. So, can I say plus 1 minus 1? If I'm doing an addition, you know the rule of mathematics, we have to do subtraction also. I'm just erasing this part so that it doesn't create any confusion. Okay, so now have a look, children. Again, whenever if the x term is positive, we will be able to make x plus 1 whole square. So these three terms are combined together, a square plus b square plus a square plus b square plus 2ab. So here we are left with plus 1 square. Now we can use the formula directly, 1 upon under root of x square plus a square. Now in place of x, you know that x plus 1 will be put. So that is not a problem. Again, under root hai, so you know the formula which has to be used, log mod x plus under root of the question plus c. This is how you will do the completing square method. Now this was a little simpler, this thing. Now let's talk about question number 11, children, where the coefficient of, I will repeat the steps again, but main thing, you people have to do it on your own. Just apply the formula. First step, dividing by 9. Again, you know the concept. If we are dividing by 9, we have to multiply also this by 9. So that means I will write 1 by 9 also outside. I hope I'm clear. Let me show you how I have done it. I've divided this by 9, children, and I've multiplied this by 9. So this 9 has gone out and this 9 has got divided by each of the term. I hope the concept was clear. All right. Now, after this, of course, dx remains. This can be simplified and written as 2 by 3x. Now, children, again, coefficient of x divided by 2 will be 1 by 3. So, 1 plus 1 by 3 whole square minus 1 by 3 whole square plus 5 by 9. Again, let's pair it up. So, 1 by 9 integration of dx x plus 1 by 3 whole square. Now, please simplify this. 1 by 9 plus 5 by 9. This is with a minus sign. If I take the LCM 9, it will be 4 by 9, children, right? So 4 by 9 can be written as 2 by 3 whole square. Again, integration of dx upon x square plus a square. Now it is without under root. That means tan inverse integration of 1 upon x, integration of 1 upon x square plus 1 is tan inverse. So here we have 1 by a tan inverse x by a plus c. Of course, you can simplify the question to get the final answer, right, children? So this is one more way to complete. Now, question number 12, and a very, very important one, and I will show you the mistake which happens in this question, children. 99% children make this mistake. Integration of 1 upon under root of 7 minus 6x minus x square dx. Now here, most of the children take negative sign common and they convert this question like this. If you remember clearly, children, under root, there is a under root in the question. So under root of minus 1 is iota. So this step is wrong. So you have to be very, very careful that from a under root, never a negative sign can go out. Okay, this is the mistake which most of the students make. Now, so this I've already highlighted. Now let's continue the question. Now, even if you want to take a negative sign common, children, you can take a negative sign common here only and write this as this. Now you can convert it into perfect square. How? X square coefficient is 1. Coefficient of x is 6. Again, 6 divided by 2 ka whole square, add and subtract. So 6 divided by 2 is 3. 3 ka whole square, add and subtract. So 3 whole square added minus 3 whole square subtracted. Now again we will combine these terms. So integration of dx upon under root of 7 minus, this will be x plus 3 whole square. Again, don't forget, अगर x के साथ पॉजिटिव साइन है तो यहाँ प्लस का साइन आएगा, अगर यहाँ माइनस का साइन है तो माइनस का साइन आएगा. कैसे? a स्क्वायर प्लस बी स्क्वायर प्लस 2ab अगर होगा तो a प्लस बी का होल स्क्वायर बनेगा, और अगर यहाँ माइनस होता तो यहाँ माइनस का होल स्क्वायर बनता. Right, children? This is the change. So since here we do not have a minus sign, so there will be it will be a plus question, plus sign. All right. And obviously this term minus 9 was left. So if I open the bracket, minus into minus plus, so plus 9. So you know how to integrate now. 7 plus 9 will be 16, children, minus x plus 3 whole square. So integration of dx under root of 4 whole square minus x plus 3 whole square. And now again you can use the formula just in the previous slide which I have told you. Now same way you can solve question number 13. Just open it and you will get a quadratic equation. Again, question number 14, children, again a hot question. Don't take same mistake, don't commit the same mistake which I've told you in question number 12. Negative sign will not come out common. Okay, same way you can do question number 15 also. Now till here it was your type 4. Now if you have a look at this question number 16 to 23, they are not of type 4 because we have a linear equation upon a quadratic equation or linear upon quadratic equation. So this is another type. So we will continue in the next video. In the next video we will learn how to integrate under root of quadratic equation. That is your type 5. It covers exercise 7.7. So you don't have to worry. I'm going in a order the way where you can remember that how integration is not that tough. It is just that you have to remember the types. Okay. So we will continue in the next video. See you all. Thank you.